Hey pre-calculus students, so in this video I'm going to go through the Chapter R test review. Remember, your test is this coming Thursday. The test review, a copy of it is available on Canvas, but it's also in your packet. So if you want to grab that right quick, just so that you can follow along with me as we go through the test review together. So let's go ahead and get started. Again, this is Chapter R test review. And feel free to skip around in this video and see what problems you need help with. Just go ahead and you can skip to those. You don't have to listen to every single problem. Just skip to the ones you need help with. So on number 1 through 5, it says simplify each of the following. Be sure to show your work. The first few problems come from section R.1, where we talked about PEMDAS and order of operations, and R.3a, where we talked about adding, subtracting, multiplying polynomials. So starting with question number 1, it says 10 minus 4, then 48 divided by 4 squared divided by 3 is inside of the parentheses. So if we think back to PEMDAS, which is what we did the very first day of school, we're going to use PEMDAS to simplify this expression, starting with the parentheses. So my first step is to simplify what's inside parentheses. And inside of those parentheses, the first thing we see is the exponent. So I'm going to simplify that exponent first. 4 squared is 16. That takes care of the exponent part. Now I'm going to keep working inside those parentheses. We have 2 division signs, so we're just going to do it left to right. 48 divided by 16 is 3. Now the next step, we're going to keep working inside those parentheses. 3 divided by 3 is 1. Now I'm going to extend that. Now that we've taken care of the parentheses and the exponents, the next step is multiplication or division, which we have multiplication. 4 times 1 is 4. And then simply subtract. 10 minus 4 is 6. So that first expression simplifies down to just 6. On question 2, we have 9 plus, inside parentheses, is 12 minus the square root of 36 divided by 6. Again, we're going to use PEMDAS to simplify this expression, starting with the P parentheses. Inside of the parentheses, we have this square root. So I'm going to go ahead and simplify that first, because that kind of goes along with exponents. The square root of 36 is 6. Now we're going to keep simplifying the inside. 12 minus 6 is 6. To keep following PEMDAS, the exponents we don't have anymore. Multiplying, we don't have any of that, but division is next. 6 divided by 6 is 1. And 9 plus 1, because that's the addition, is 10. So in number 2, that simplifies down to simply 10. On question 3, we have this expression, 5y minus 3 times 6y plus 2 minus 4 times 8 minus y. This is also an algebraic expression. We're going to simplify by combining like terms here. But before we do that, we need to get rid of these parentheses by using the distributive property. We talked about this in Chapter R. I'm going to multiply negative 3 through those parentheses, as well as the negative 4, which leaves us with negative 3 times 6y is negative 18y. Negative 3 times 2 is negative 6. Now the second set of parentheses, we're going to do the same thing. Negative 4 times 8 is negative 32. And negative 4 times negative y, remember you could say there's a 1 in front of that y, Negative 4 times negative 1 is positive 4. And then we're going to tack on the y at the end. Now that we've gotten rid of the parentheses, I'm just going to combine like terms together. 5y minus 18y plus 4y, all of that simplifies down to negative 9y. Now the constants, negative 6 minus 32 is negative 38. We cannot combine those terms together because they are not like terms. The 9 has a y with it, but the 38 does not. So that is what that expression simplifies down to be. Negative 9y minus 38. On number 4, it's kind of long, but we can still do it. We have the expression 15 minus bracket 5x squared plus 6, parenthesis 9 minus 3x, close parenthesis and put a bracket, plus 3/4 times 4x squared minus 8x. This is an algebraic expression. We're just going to simplify it. You'll notice here, though, we've got brackets and parentheses. Remember, when you have both types, you're going to work on the inside out. So I'm going to simplify the inside first by distributing that 6 through, which gives us 15 minus bracket 5x squared. 6 times 9 is 54. 6 times negative 3x is negative 18x. I'm going to keep that bracket there. Plus, now I'm going to distribute the 3/4 through that set of parentheses. 3/4 times 4. Remember, you multiply 3 and 4 together to make 12 over 4 in the denominator. 12 over 4 simplifies to 3x squared. 3/4 times negative 8. I'll do that right here. 3/4 times negative 8. Remember, you can put a 1 underneath if that makes you feel better when you multiply fractions. And we're going to multiply straight across. 3 times negative 8 is negative 24. 4 times 1 is 4. And that divides to be negative 6. So this is minus 6x. Now we're going to keep simplifying. We've got these brackets on the inside part to take care of. So to get rid of the brackets, I'm going to distribute that negative through the brackets. Negative 1 times 5 is negative 5x squared. Negative 1 times 54 is negative 54. Negative 1 times negative 18 is positive 18x. Now that I've distributed, I don't have those brackets anymore. So that's what the distributive property does. I'm just going to tack on that ending part. All right, now that we've gotten rid of parentheses, we've gotten rid of brackets, we're ready to combine like terms together. Negative 5x squared plus 3x squared is negative 2x squared. Now I'm going to look at the x's. 18x minus 6x is 12x. And last is the constants. 15 minus 54 is simply negative 39. And that is what that expression simplifies down to be. On the next question, question 5, says we're taking 3x plus 1, and I'm going to multiply it with 4x minus 2. To multiply two binomials together, there was an acronym that we learned how to multiply two binomials together, and it was FOIL. So we're going to FOIL these two binomials together. Starting with the first term, 3x times 4x. 3 times 4 is 12. X times x is x squared. So that is 12x squared for the first term. O stands for the outer terms. 3x times negative 2 is negative 6x. I stands for the inner terms. 1 times 4 is 4x. And then the last letter L stands for the last two terms. 1 times -2 is -2. Now that we've multiplied, I'm going to go ahead and combine like terms together to simplify this. 12x squared does not have any other like term, so I'm going to leave it 12x squared. -6 plus 4 combines together to make -2x. And the -2 at the end here does not have a like term. So that is the simplified form of that expression. Starting on question 6, it says to factor each of the following completely. The next few problems that we go through on our test review come from section R.3, where we learned about different factoring strategies. So starting at question 6, it says x squared minus 100 is what we're going to factor. First step is to always check a GCF, the greatest common factor. But you'll note that there's not one here because they both don't have an x in common, and they both are not divisible by any other term except for 1. So no GCF. Now we think back to our factoring strategies. This one just so happens to be a difference of perfect squares. So I'm going to factor this by taking the square root of both terms. X squared has a square root of just x. The square root of 100 is 10. So those are my two factors. Now we put minus and plus in the middle. So that's how you factor number 6, because it was a difference of squares. On question 7, it states to factor x squared minus 4x minus 32. There is no GCF here, so no greatest common factor to pull out. Now, because this has 3 terms, we're going to first label. This is A, B, and C. To factor a trinomial, we first need to find 2 terms that multiply to make AC. 1 times -32 is -32. And then B is -4. So on either side of this x, we need to find 2 terms that multiply to make the top, but add or subtract to make the bottom. Now after you go through your factor pairs, 8 and 4 make 32, but in order to make that a -32 and this a -4, that's going to have to be a -8. -8 times 4 is -32, and -8 plus 4 is -4. Our next step is to rewrite this trinomial with these 2 values in place of the -4x. So I'm going to keep the x squared. -8x comes from this factor. 4x comes from the other factor. And minus 32 goes at the end. So all I did in that step was rewrite -4x with those 2 factors that we just found over to the right. Now since we have 4 terms, I'm going to factor this by grouping. Put our parentheses around the first 2 terms and the last 2 terms. Next step is to pull out the GCF out of both sets of parentheses. So out of the first set of parentheses, they have an x in common, which means I can factor that out of each term. In the second set of parentheses, they have a 4 in common, so I'm going to factor out a 4 out of both of those terms. Now you'll notice in this step, this x minus 8 is the same, so I can factor that out of both the terms and put the x plus 4 together. And that is now completely factored. On question 8, it states for us to factor 4x squared plus 9x plus 5. Again, this has no GCF because 4, 9, and 5 are not divisible by anything but 1, so no GCF to worry about. This does have 3 terms, so I'm going to factor it just like I did the last one. Start out by labeling A, B, C. Come over here, we're going to make our X. A times C, or 4 times 5, is 20. The B is 9. Two numbers that multiply to make 20, but add or subtract to be 9, are 5 and 4. Now I'm going to rewrite this expression using the 5 and the 4. So here's the 4x squared term. 9x we're going to split apart into 5x and 4x, and those were both positive. And then the plus 5 goes at the end. So again, all I did there is break up that 9x. Because there are 4 terms, we're going to factor this by grouping. In the first set of parentheses, they have an x in common, so I'm going to factor that out. And in the last set of parentheses, they don't have anything in common, but remember you can always divide by 1. So I'm going to divide both of those terms by 1. Now as we look at this step, you'll notice that these have a 4x plus 5 in common. So I'm going to factor that out of both terms. And the remaining parts, x and 1, we're going to stick together. So the x plus 1 factor is in parentheses. And that is completely factored. So number 7 and number 8 were very similar to each other because they were both trinomials. Question 9 states for us to factor x cubed minus y cubed. These do not have a GCF in any factors in common. This is, though, a binomial. Specifically, it's a difference of perfect cubes, DOC. So how we factored this, there was a special rule. A minus b cubed factors into a minus b times a squared plus ab plus b squared. I'm going to use that rule that we learned about in our notes to factor this expression. X cubed minus y cubed, the first thing is to take the cube root. The cube root of x cubed is just x, minus the cube root of y cubed is just y. So there's the first term, that a minus b, which in this case is x minus y. To get the next term, I'm going to square the first letter, which is x, plus, then multiply the first and the last term together, x times y, plus, and then square the last term to make y squared. That is how you factor a difference of perfect cubes. On your test, depending on what form of the test you get, you may have a difference of perfect cubes or a sum of perfect cubes. Just make sure you know how to factor both kinds of expressions. On question 10, states for us to factor 2x cubed minus 10x squared plus 12x. On number 10, you'll notice that this is a trinomial and there is a GCF. The GCF here is 2 because all of the terms are divisible by 2 because they're even, and they also all have an x in common. So I'm going to divide each number by 2 and pull out an x, which leaves us with x squared minus 5x plus 6. Now that we pulled out the GCF, this is still a trinomial, which means we can try and factor it. Label ABC. A times C, or 1 times 6, is 6. B is the negative 5. Two terms that multiply to make 6, but add or subtract to be negative 5. are -2 and -3. And you can go through your different factor pairs to make 6. And the only two that will work, though, for this expression are -2 and -3. Now, just like the previous ones we did, I'm going to leave x squared and rewrite -5x with these two factors of -2x and -3x. And then bring down that +6. Make sure you're also bringing down your GCF, that 2x in each step. Since the inside has 4 terms, we're going to group to factor this. X squared minus 2x has a common factor of x, and I'm going to pull out of both terms. -3x and 6 have a common factor of -3, which leaves us with x minus 2. The inside of the parentheses, the innermost part, has a common factor of x minus 2. So I'm going to now pull that out and group the x minus 3 together. And that is how you factor that expression. The last one on this first page is number 11, which states to factor 2x squared plus xy minus 12x minus 6y. First thing you always check is that GCF, but there's no GCF here, so no need to worry about that part. There are 4 terms this time, which means we're going to factor by grouping. Group and group. The GCF out of the first 2 terms is x, which leaves us with 2x plus y. The GCF out of the last 2 terms is -6, which leaves us with 2x plus y. These terms have a common factor of 2x plus y, which means we can factor that out because it's their GCF. And group what's left, the x minus 6 together. And that is how you factor that expression. So those problems 6 through 11 are just a little bit of review for you over factoring from what we did in chapter R. Starting at question 12, 12, 13, and 14 all came from section R.1, where we talked about evaluating expressions. Remember the word evaluate? When you see that, it simply means to substitute in. So number 12, here's 2 pi RH plus 2 pi R squared. And we know that R is 5 and 8 is H. Because we're evaluating, I'm just going to take the R and the H and substitute them in for R and H in the expression. Start off with 2 pi is, we're just going to leave because the directions say leave in terms of pi, so we're just going to leave pi. In place of R, I'm going to put the 5. In place of H, I'm putting 8. I'm going to do the same thing with this last part, substitute in 5. Now we're just going to simplify. 2 times 5 times 8 is 80 pi plus 2 times pi. 5 squared is 25. So that last part we can actually simplify. 2 times 25 to be 50 pi. And combine those like terms together because they both have a factor of pi. 80 plus 50 is simply 130 pi. And that's all that evaluates to be, 130 pi. On question 13, we have another expression, 4/3 pi r cubed for r equals 3. Again, our directions state to evaluate, so we're just going to substitute this 3 in place of r and simplify. 3 goes in place of r. 4/3 pi. 3 cubed is 3 times 3 times 3, which is 27. Now if we do some cross simplifying here, I'm going to change this 27 to a fraction because this 4/3 is already a fraction. Since you will not get a calculator on the test, it's best to go ahead and simplify before you multiply. So I'm going to cross simplify. 3 divided by 3 is 1. 27 divided by 3 is 9. 4 times 9 is 36 pi. And then the denominators, I'm going to multiply those together. 1 times 1 is simply 1, which just gives us 36 pi for our final answer. On the last one on this section, question 14 says L, W, H, those are all multiplied together. 4L equals 2W, and H equals 5W. So in place of L, I'm going to put 2W. In place of W, I'm just going to keep W. And in place of H, I'm going to put 5W. Now to simplify, we're just going to multiply all of these terms together. 2 times 5 is 10. And then we had 1, 2, 3 W's, which makes 10W cubed for your final answer on that expression. On questions 15 through 20, the last part of your test review, this comes from section R.3 as well. It's just more practice with factoring, but this time we are asked to solve by factoring. Just kind of a reminder, whenever you are solving by factoring an equation, the equation must equal 0 before you can start factoring and messing with it. So we first want to make sure our equations are set equal to 0 before we factor. So let's go ahead and start with 15. It says x squared minus 64 equals 0. This equation is set equal to 0, so we're good to go ahead and factor the left side. X squared minus 64 does not have a GCF, but it is a difference of perfect squares. So I'm going to factor by taking the square root of both of those terms. The square root of x squared is x. The square root of 64 is 8. And stick a plus and a minus sign in the middle. Now that we factored, we can go ahead and solve by taking each factor and setting them equal to 0. We did examples like this in class. You guys did a big puzzle online or on paper that was practice with solving. To solve for x, I'm going to subtract 8 to both sides. So x equals negative 8 is one of our solutions. And then add 8 to both sides. So that x equals positive 8 is another solution. So negative 8 and positive 8, those are solutions to that equation. On question 16, it asks us to solve n squared minus 12n equals negative 36. First step is to make that right side equal to 0 by adding 36 to both sides. So now this is a trinomial with positive 36 at the end and set equal to 0. Now that it's set equal to 0, we can go ahead and factor. This is 3 terms, no GCF. This is A, B, and C. A times C is 36, and B is negative 12. 2 terms that multiply to make positive 36, but add or subtract to be negative 12. Those 2 values are negative 6 and negative 6. You can go through your factor pairs to make 36, but 6 and 6 are going to be the only ones, and they both must be negative to make negative 12. Now we're going to rewrite this. negative 12n as negative 6n, and negative 6n using these two factors that we found. Plus 36 equals 0. This polynomial now has 4 terms, so we're going to factor by grouping. Group and group. The GCF out of the first 2 terms is n, and out of the last 2 terms is negative 6. And I'm pulling out that negative with the 6 because this first term was negative. Now, they have the n minus 6 in common, so we can factor that out next. And group the n minus 6 together. And this is still equal to 0. Don't forget, you need an equal to 0 there. I dropped it, but don't forget, it's important. Because now that we factored, we can solve. Set each factor equal to 0 and solve. Add 6. So that n equals 6 is one solution, and n equals 6 is the other solution. So n equals 6. It appears twice, so you can write it like this. n equals 6, comma 6. Or you could write 6 m2. The m stands for multiplicity. It's how many times that the 0 occurred. It occurred twice. So either way, regardless, 6 occurs twice. On question 17, it asks us to solve by factoring 3r squared minus 8r minus 3 equals 0. This is a trinomial. It's set equal to 0, which is good because we're solving it. When you look at a trinomial, you want to make sure you pull out the GCF first. But there's no greatest common factor because the terms do not share an r, and the a, b, and c here, the 3, 8, and 3, they don't have any other common factors besides 1. So GCF we checked, there was none. There are 3 terms, which means we're going to factor this, kind of like we've done the previous problem. A times c is negative 9. B is negative 8. 2 terms that multiply to make negative 9, but add or subtract to be negative 8 are negative 9 and positive 1. Those multiply to make negative 9. They add or subtract to be negative 8. So now I'm going to rewrite this using those 2 new factors. Negative 9r and 1r minus 3 equals 0. This step gave us 4 terms, which means we're going to factor this by grouping. So I'm going to group and pull out the GCF out of both pairings. Out of the first terms, 3 and r are the greatest common factors, which leaves us with r minus 3, plus, on the next set of terms, r minus 3 does not have any GCF except for 1, which leaves us with 1, r minus 3 equals 0. These both have common factors, which means we can factor that out as well. And stick the 3r plus 1 together. Now that we've factored the left side, we're going to solve by setting each factor equal to 0. And the next term, 3r plus 1 equals 0. Now we're going to solve for r by adding 3 to both sides. R equals 3. By subtracting 1 from both sides and dividing by 3, r is equal to negative 1/3. So those are our 2 solutions to that equation, r equals 3 and negative 1/3. On question 18, we're factoring to solve the equation 12x squared plus 8x equals 0. This is already set equal to 0, so it's good for us to go ahead and start factoring. The left side, 12x squared plus 8x has a GCF remember you pull that out first, of 4 and x. So I'm going to divide both terms by 4, which leaves us with 3, and pull out an x. Divide 8 by 4, and pull out the x, which leaves us just with 2 there, equals 0. I cannot factor that left side anymore because we already pulled out the GCF. So now it's time to solve. Split the factors apart and set them equal to 0. To solve this first side, I'm going to divide both sides by 4 so that x is 0. To solve this other equation, I'm going to subtract 2 to both sides and divide by 3 to get x by itself. So x is equal to negative 2/3 and x equals 0 are the solutions to that equation. On question 19, we're solving by factoring the equation x cubed plus x squared minus 9x minus 9 equals 0. This equation equals 0. On the left side, there is no GCF, so they don't have any common factors, which means we're good to go ahead and factor. On the left side, there are 4 terms, which means we're going to group. Anytime you have 4 terms, always use factor by grouping first. So I'm going to factor the GCF out of the first 2 terms. They have 2 x's in common, so I pull out 2 x's. X squared divided by x squared just leaves us with 1. Remember, you have to have that 1 there as a placeholder for the x squared term. The negative 9x minus 9 has a GCF of negative 9. So I'm going to divide both terms by negative 9, which leaves us with x plus 1 and then the 0 at the end. These terms are in common, so I'm going to pull that out as well and group the x squared minus 9 together. You can factor this a little bit more because this piece is a difference of 2 perfect squares. So I'm going to factor this just a little bit more. Take the square root of both terms. The square root of 9 is 3. And put plus and minus in the middle. That's how this one factored. And set it equal to 0. Now that we factored everything on the left side, we're ready to solve by setting each factor equal to 0. And you can do this probably in your heads, or you can just show your work on here. Subtract 1 to both sides, so x is negative 1 for the first term. Subtract 3 to both sides, so x equals negative 3 for the second solution. And add 3 to both sides, so x is 3 is the third solution. Those are your 3 solutions, negative 3, negative 1, and positive 3 for that equation. The last question on your test review gives us the equation x squared minus 2x minus 35 equals 0. This equation is already solved for 0, it's set equal to 0. And we don't have a GCF. So GCF, there is none, because there's not an x that they have in common, and 1, 2, and 35 are not divisible by any other common factor except for 1. And dividing something by 1 doesn't do anything, so no GCF to pull out. There are 3 terms here, so we're going to need to factor. A times C is negative 35, B is negative 2. 2 numbers that multiply to make negative 35 and add or subtract to make negative 2. That's what we want to think about. 2 numbers that multiply to make 35 are 7 and 5. How that could make negative 2, though, is if we make this 7 a negative, and those multiply to make negative 35. So now let's rewrite this. X squared Using these two factors, I'm going to rewrite negative 2x is negative 7x plus 5x minus 35 equals 0. There are 4 terms here, which means we can factor by grouping. So I'm going to group these terms together and pull out their GCF. The GCF out of the first 2 terms is an x, which leaves us with x minus 7. The GCF out of the last 2 terms is positive 5, which leaves us with x minus 7 when we divide both terms by 5, equals 0. These terms are in common, so I'm going to factor that out as well and stick the x plus 5 together. Don't forget to set equal to 0. Now that we factored the left side, we can split the factors apart and solve. Set each factor equal to 0. To solve, I'm going to add 7 to both sides. So that x is positive 7. To solve for the second solution, I'm going to subtract 5 to both sides. So that x is negative 5. And those are your 2 solutions to that equation, positive 7 and negative 5. That's the end of your test.